Hello, my name is Ben Consalvo. I am a staff AI software engineer at Intel, and today I have something very exciting to share with you. I built an Agentic system using the open source framework AutoGen, and so the kind of the motivation behind building something like this for healthcare providers is to be able to reach out to patients in a preventative screenings. And this system is designed to help you to automate this process of identifying patients who meet specific needs, screening criteria, and it's really about this collaborative nature that usually happens between doctors and epidemiologists and data analysts who come up with some of these both screening criteria and then send out some notices for patients to check on certain healthcare needs. So one of the first things I wanted to do actually was just run the application and show you how it's working. So on the left panel here we have some different prompts that I've created for the different agents, and I'll get much more into detail of that later. But yeah, these can be modified, and the really cool thing is they use this natural language understanding to implement what they're trying to do. And the next element is the actual patient data, and in this case I've synthetically generated some data and to use, and then I have a medical screening task of a colonoscopy screening, and then I have some contact information to provide at the bottom of the email. So I'll go ahead and click generate outreach emails, and we'll start to see this in action. So what I have here on the screen is an activity log of kind of what's happening. So starting the agentic workflow, and yeah, it's actually already completed the task. So these outreach emails have been generated, and we can click on maybe an individual email or download all the emails and can pull this open, and yeah, we can see that I've generated a draft of an email for a screening that's personalized to patients from the database. All right. So some of the key things that I want you to be able to walk away from this is that you can create this agentic AI application on Hugging Face yourself, or you can actually host it elsewhere as well. And then I want you to become familiar with AutoGen agents. So I'll walk you through some of the agents that I've built here with AutoGen. And then I want you to be able to bring your own OpenAI compatible API key and model endpoint and be able to build this yourself. So what I'll do is kind of walk through the building of this application and kind of the steps that you need to take as a user that I've built into this. So what I'm highlighting here on this screen is the user provides a very broad screening criteria, so like I did the colonoscopy screening, and then the system uses different agents to generate patient-specific criteria, filter patients from a database, and generate outreach emails. So like I showed you, you can use the sidebar on the left of the UI to customize prompts, select the data set and the medical screening task, and then generate the emails. So it is a multi-agent system built on top of AutoGen, and it uses a lot of multiple agents, large language models, and asynchronous programming to ultimately generate these emails. And the system uses model endpoints hosted by Denver DataWorks on Intel Gaudi accelerators and an OpenAI compatible API key, like I mentioned. So if we go actually to the Denver DataWorks website, it's a cloud provider, and these are some of the foundation models that are currently supported, and these are being added to all the time. So we have Llama models, DeepSeek, Mistral, Qwen, And like I mentioned, the nice thing is it's OpenAI compatible. So you just need that API key, and yeah, very cost efficient. It runs really fast, and yeah, these are this is a great way to get started. But what I wanted to mention here as well is that you can really use any cloud service provider, and any model endpoint, as long as you have this OpenAI compatible API key. And the two models that I'll showcase here are Llama and then DeepSeek, and I'll get into those a little bit more. So the actual application is hosted on something called Hugging Face Spaces. Many of you may be familiar with this, but if you're not, it's a way to host machine learning applications. And when you have an account on Hugging Face, you can just go to create new space, and then you name your space, and start with kind of what front end you want to use, and you actually can host these for free, on some basic CPU architecture, and then you can make them public or private. So once you've created this space, what you can actually do is you can clone it just like you would a GitHub repository, and then you can kind of modify the code and then push the code right back up to Hugging Face, and build out your front end UI with whatever back end you have. In my case, the back end is AutoGen, and then the front end is Streamlit. So AutoGen is an open source framework started by Microsoft, and so here's the GitHub repository, and it's already quite popular. It's 45,000 GitHub stars, and it's an Agentic AI framework that's grown pretty quickly, and they have their own Discord, that highlighted at the top there. And it's pretty easy to use. They make an interface. There's both like the CLI, like the command line interface, and then there's also like a studio front end that you can use to build your agents. So with that, I'll return to our application and kind of walk you through the AutoGen workflow. Actually, before I do that, I just wanted to highlight that the original idea comes from Mike Lynch on his Medium blog called Hospital GPT. And so I've basically taken his idea and heavily modified the code and some of the agents and the prompts for this medical screening task. So I wanted to walk through this workflow, which is we have, the user will input some kind of screening task that's very broad, like type 2 diabetes screen I have listed here. And then it'll pass it to what's called a group chat manager. So this is specific to AutoGen, and essentially this group chat manager coordinates the chatting between the agents. And so I have 3 agents here. One's called user proxy agent that really represents the query of the user to these other agents. And so the next agent is called an or assistant agent from AutoGen, and then I've called it an epidemiologist. And that epidemiologist will actually, between this epidemiologist and the doctor critic, will define the criteria for patient outreach. And what this epidemiologist uses is a Llama model, and it's hosted. That's why I have this meta symbol, for the Llama model, and then it's hosted on the Intel Gaudi infrastructure that's like an accelerator that's hosted on this Denver DataWorks cloud. So then the assistant agent, the next assistant agent, the doctor critic, will take some of the recommendations from the epidemiologist and either accept, approve, or revise some of those patient criteria that they should be looking at based on the initial screening criteria that the user provides. So the output of this group chat manager, this chat between these different agents, is health screening criteria. So I've noted here the output criteria is age range, gender, and relevant medical history. So the next part, after we get this health screening criteria, I actually pass it to another group chat manager that's between another user proxy agent, which is really just, a proxy for this criteria to the assistant agent called data analyst. So it's providing this, this output of this criteria directly to the data analyst. And then really what the data analyst does is looks at the patient data from the database and looks at the criteria and filters those patients down to the ones that actually would be relevant for this kind of medical screening. And so the output is the filtered list of patients and, from that database. And then the last part is actually using an LLM to generate the emails. And in all cases, or most cases here, like the agents are leveraging different LLMs to understand and to work with one another on their various tasks that they have. So mostly I'm using the Llama 3.3 70 billion parameter model, but also I'm using a DeepSeek 70 billion parameter model for the doctor critic here. And so the ultimate output, like I showed you, is emails to these patients, and they are draft emails that you can look at and approve or change a little bit. But the idea is that it would help doctors and teams of healthcare providers to be able to automate some of these tasks. All right, so with that, I actually wanted to show you in a little bit more detail the customizing these agent prompts, because some of the key here is the natural language understanding that these agents and these LLMs have kind of built into them. So the first one is the user proxy prompt, which is where the user provides criteria. So I'm telling the agent that it will provide this criteria for the patients and giving it some examples. I'm just saying this is the only time that this user agent should be called. So it's the only initial input really is this this user screening task. And then I have below that the epidemiologist prompt. And so this one's a little bit more detailed. So I'm defining it as an epidemiologist, and I'm telling it that you're an expert in autonomous agent for the healthcare system who will define the right criteria. And then I give exactly what the criteria should be. So minimum age, maximum age, gender, one previous condition. And then saying you're going to get a very very broad and generic screening phrase from the user, and then giving those examples again, and you're going to provide the specific patient criteria for the outreach. And then if the user provides like a very unrelated screening task, you should just kind of end the conversation there and ask for an appropriate screening task. And then I give 5 examples of output. So this is like that idea of few shot learning with the LLMs. So I'm giving it 5 examples of output criteria, of here's what it should look like. You should have a patient age range, you should have genders, and then or with like a specific condition. So the idea is that taking the information from this output, the LLMs can actually match just in a natural language understanding kind of way with the descriptions that are in the patient database. So the patient database isn't just like single variables or single pieces of text. It's sometimes whole descriptions, and I want the language model to be able to identify from that database, who should be be the targets for the outreach. And just concluding with you must only reply with one set of criteria, and then state the reasoning before you state the criteria. All right, so that's the epidemiologist, and then the doctor critic is the one who reviews the recommendation from the epidemiologist, And so I'm using a different model, like I mentioned, the DeepSeek model for this. And specifically, you check on the following: that the recommendation from the epidemiologist relates well to the preventative maintenance task from the user, and that the criteria, meets the standards that I've given it with age, gender, and previous condition. And then I'm just telling it to restate the reasoning and be explicit about whether or not it agreed, and how to proceed from there. So the cool thing about this application, and just about these agents and LLMs in general, is that you can actually redefine some of these prompts and get the agent to do something different than what I've written here. So if you have kind of a more custom use case, but it still relates to this overall task, then you can update this and manage the differences. And then it says press Control Enter to apply. So just to apply the changes, if you made any, you can apply them there. And then finally, the email template prompt. So this is taking into consideration all the information from the filtered patient list, generate an email, and then I just kind of outline what I want the email to say and what I don't want it to say. So I'm saying it should be no more than 200 words. I want to make it short. People don't like reading a lot of emails or long emails. So the name of the screening required, from the user proposal, and to contact the doctor's office. And because I want the email to be very succinct, I'm not asking to provide a lot of medical details or history in the actual email, and not to provide any reasoning for the screening to make someone maybe more nervous, and then always end the email with a certain way, with best regards and name, phone, and email. And then not to include any disclaimers. So I'm being very specific here. And like I said, you can actually modify this so that the agent will, or the LLM will take what you provide and generate the consistent email. One of the things that I found in building this is that one of the things that helped keep this consistent with the LLM was to set the temperature to 0, which is a parameter of kind of creativity for the LLM. So essentially that's saying be as consistent and uncreative as possible while sticking to the prompt. So those are the prompts, and the next part I wanted to show you is the patient data and screening task. So like I mentioned, what I did was I'll pull this over here and make this a little bigger. I generated some synthetic data of patients, and the columns here are patient ID, first name, last name, email, patient diagnosis summary, age, gender, and then a condition if there is one. So these are all generated, and these are what the LLMs can look at and make some assessment over whether or not this particular patient should be called in for screening. So I'll minimize that, and so that's the data set, and you can bring your own data set. And really, this code could be easily modified to bring in a different kind of database other than just a CSV file that I've placed here. So the other thing I wanted to point out is that there is a really useful website called US Preventive Services Task Force, and I'll open that here. And so this is a listing of recommendations of screening tasks for the medical community. So it gives like a specific topic and what's recommended for screening for this particular medical condition. So for example, there's one related to BRCA related cancer, and what's kind of recommended for this particular breast cancer So these are really helpful if you're not very familiar with the different kinds of recommended screenings. So as you're looking at your screening task, this is something that you could reference. So, and then the last couple things on the UI here is the actual medical screening task. So like I mentioned, the default one is colonoscopy screening that I've put here, but we could put breast cancer screening if we wanted, and then we can enter our provider information for the email. So I'll go ahead and run this again, and I'll go back up to the top and look at the app to see. Okay, so yeah, it's taken this new screening task of breast cancer screening, and then having this these agent conversations. So the criteria result says that for breast cancer screening, primary consideration is for individuals high risk of developing breast cancer. That's pretty obvious, yeah. The minimum age is 40, maximum age 80, but in some cases might be higher. But for the purpose of this screening, 80 will be used. Then the gender is set to female. And then if there's any previous condition of this fibroedema of breasts as considered. So that's the criteria that was generated. And then, this conversation kind of happens between the different agents, and kind of a showing of the summary of each agent. We can look at the epidemiologist, which we just looked at. We can then look at the doctor critic, and assessing whether this is a reasonable screening and reasonable patient criteria. So it's restating that, and then the data analyst agent is actually doing a tool call to look at this specific patient data, and then with the criteria that have been recommended. So we have the minimum and maximum age, and then we look at, okay, it's called this tool, this get patients from criteria, with the arguments that it's extracted from the text, and then it actually kind of shows the selected patients that meet the criteria that have been outlined. So there's 13 patients that have been selected, and lists just kind of a summary of some of the data there. And then this is where the LLM that's built for generating emails starts to generate those emails, and we can download all of them, text files as a zip file, or just look at some of the emails as they're generated. So I'll pull this one open, and we'll see the kind of how the email is written. I'll zoom in a little bit here if I can. Okay. So I hope this email finds you well. We're writing to you for a colonoscopy screening. And then later on to arrange a follow-up appointment, please do not hesitate to contact our office by email or phone. And then please feel free to reach out to us. So a friendly email for this screening. And so that's kind of showing in more depth how this works, and the fact that we can then go and look at some of these emails. All right, so the next step that I wanted to show you is, if you wanted to run a local copy of this application, I've given some instructions here, and I'll actually walk through kind of doing that to show you, what's possible, so you can run this in your own kind of Streamlit front-end UI without Hugging Face, or if you just want to run, it from the command line as a script. I also have that here. So the setup that I have here that you can also follow along with, what I'll do is I'll pull open my VS Code window here, and then yeah, the instructions on the left. So here's VS Code, and I'll shut this side panel so it's a little bit easier to read. Okay. So the setup, like I mentioned, you can just git clone the repository from Hugging Face, and so I'll go ahead and do that. And what I'm using is UV, which is a package manager, kind of similar to pip, but I like it. It's I think a little bit better. And yeah, so once we've gone into this directory, we can see all the files that are there. And so what I'll do first is I'll initiate this with UV, and I already have this pyproject.toml file, which kind of outlines all of the packages that are needed. So I'll do this UV init and the UVVNV. So the UV init, I already have this pyproject.toml file, so it didn't need to do that, but it did create the virtual environment right in this folder. And then I can activate that virtual environment. So now I've activated this preventative healthcare environment, and then I want to make sure that all the dependencies are installed. So I do that with UV sync, and then yeah, if you're already kind of done running your application, you can just put this command in, deactivate. All right, so now that we have this environment set up, what we need to do, and the cool thing that I mentioned is that you can add your own OpenAI compatible API key and the model endpoint. And so in Hugging Face, you can actually do it under Hugging Face settings. So I'll show you that first, like if you're deploying it right on Hugging Face. So you can scroll down once you're into your settings for this specific space. You can scroll down and find a section called Variables and Secrets. And so what you can do is create a new variable or secret, and you can say OpenAI API Key, and then enter your whatever your API key is there, and it keeps it hidden. So even though your space is public, you don't have to expose any of your secrets, your API secrets. And then I also have a OpenAI base URL. That one actually doesn't have to be secret, but I've placed it in there as well, and you can access that with like a Streamlit command that I'll show you. So yeah, the command is actually used in my code in the app.py code. So it's just this streamlit.secrets, and then I just reference the OpenAI API key or the OpenAI base URL, and that base URL is like the model endpoint URL that I'm accessing. So yeah, that's a really cool feature with the Hugging Face spaces. But if you are deploying a local version with Streamlit, like as the Streamlit front end just on your your local device, you can add your details under a file called .streamlit/secrets.toml, and I already have that file prepared, but so what I'll do is I'll copy that that file that I've already prepared right into the the directory for this new Git repository, and then I have that with my API key as well as the OpenAI base URL. So coming from the Denver DataWorks server using this chat completions API from OpenAI. And then finally, if you just want to use a Python script without any Streamlit front end at all, you can just add your API key to this OAI config list file. It's a JSON file, and it looks just like this on the left here, and essentially says, here's the name of my model, here's the base URL, Here's my API key, which I haven't populated here, but I have it in my command line here on the right, so I can go ahead and copy that OAI and then just copy that directly into here because I've already prepared that beforehand. And then if you want to modify the prompts, like I showed you, you can do it in the UI on the left sidebar that I've created, or you can just edit the files that I've highlighted here. So I'll just open up those so you can see it, but it's the same thing that was on the UI. So it's just pulling from these files directly from the Hugging Face repository here. So yeah, you can modify all those like in your code editor if you wanted to. So if I look for those, I can find, let's see, we can go here and open up one of these prompts, and you could just edit it right in your code editor if you wanted to. All right, so now looking at the example usage, if you want to run the app with Streamlit locally, you can do it just with the Streamlit command, assuming you have Streamlit installed, which I should with the requirements that I put in for the install files. So if I do a Streamlit run app.py, I should get a new version of this opening up in my browser window with Streamlit. So, and then let's go, open in browser. Okay, now as you can see here, we do have the whole application running, and this is just running locally. Well, locally on my device, but what's actually happening with the models is that they're still pinging those models in the cloud that are sitting on Denver DataWorks. And like I said, or anywhere else where you want to ping these hosted models with an OpenAI API key. And let's actually make sure that it works now that we've deployed it locally instead of on the Hugging Face platform. Okay, so we're starting to see the agents working, and for this colonoscopy screening, loading the patient data and then working through generating the emails. And when you do this locally, you can actually write directly to your system. So I have it writing to this data directory. So if I go back to our code here, I'll just make this full screen. So we should see under data, we should see a whole bunch of emails, which we do. So there's the emails that have been generated that have been saved locally on our device. Okay. So that's the the local Streamlit version if you wanted to just run it locally and still be able to ping those models in the cloud. And then the other possibility is that I've created. If you don't want to do a whole front end interface and you're comfortable with just using a back end only version, what you can do is just run a script with some arguments that I've outlined here. And so I'll go ahead and copy that and run that locally, that script. So clear this out. And then run with this this script, which is really what the app.py is calling. And you can take a look at the log that's happening with the epidemiologist and the doctor critic, back to the user, and then looking at the database and generating the emails. And so there's three different ways you can run it. The first two with front end interfaces. And then the last one just with command line. So those are three ways you can run this. And this one I've actually already closed, but I still have the Hugging Face space one running. That one's running all the time. And so that's those are the the arguments you would provide, very similar to what I've provided in the interface, just from the command line. And lastly, I just wanted to share some of the lessons that I learned in the process of building this. So what I found was that some LLMs perform better than others at certain tasks, which might seem very obvious, but in practice, you often need to adjust what LLMs you're using for specific tasks. So one of the examples I'll give is that I found that the Llama 3.370B model was much more consistent when I was generating emails and hallucinated less than the Mistral model for email generation. So I ended up using the heavier duty Llama model for this. But there are definitely cases where you want to use smaller models that take up less of a model footprint or memory footprint. Like you could actually ping a model that you're hosting locally on your device, or a smaller cloud server that doesn't cost you as much. So for example, you could host one on like a CPU, and potentially get the same result if you're finding that LLM with the smaller memory footprint does just as well. I mentioned this in the middle too, that setting the temperature to 0 is important for getting consistent output response from LLMs. So in my case, for this problem, I just ended up setting this creativity level to 0 across all the models after experimenting with some different temperature settings. So prompt engineering is very important in the age of instructing LLMs on what to do. My top 3 tips are to be very specific and detailed. So you can see from my prompts that I've written pretty extensive outlines of what I want the LLMs to do. And then give exact output formats. So if you want the LLM to produce a certain output format that you're looking for, just give some examples for it to be able to replicate. And then tell the LLM what to do rather than telling it everything it shouldn't do. I do in my prompts put some things that it shouldn't do, because I want to make sure, after I iterated some, I wanted to make sure that it wasn't doing some things that it tended to do. But telling it what to do, for example, I would say, write this email in 200 words or less. So I want to make sure that it understands, hey, I want this to be a short email. So that's an example. And there's actually an OpenAI blog where they outline some best practices for prompt engineering that I've linked. So yeah, this goes into much more detail, but some helpful tips that I've used when I've been building these different prompts. Number 4 is one that I found interesting as I was building out these agents. And that's that sometimes building a simple tool is easier to manage, like with traditional programming, rather than building an agent to do it. The example that I'm giving here is that sometimes the agents would say that they're accessing a database and then not actually access it, but invent some patient data and then say that the data was from the database. So like I mentioned here, when I started this project, the LLMs were inventing data that were not part of the database, even though I clearly instructed the agents to use data from the database. So to resolve this, I made sure that the agent was doing a tool call using a specific function to read from the database. And this may get better, and there may be other models that do better with this task without having to create such a specific tool for it to use. But this is what I found when I was building this. Number 5, do operations asynchronously wherever possible. This might seem obvious, but parallel programming is important. So if you can run tasks all at the same time, then do that. So at first I was just having the emails all written in one by one in a for loop, but then it's like, oh, this is taking too long. I want them to all be written at once. I'm sure that the CPU can handle that, and it could. It was ready. So it made them, it wrote the emails in seconds rather than maybe a minute or something. So number 6 is that I did use some code writing tools to interact, to build this app out a little bit further. And they can save a lot of time. Tools like GitHub Copilot, Cursor, Windsurf, and there's lots of others out there. But what I found is that you really do need to still pay attention to the output and understand what's going on with the code. So a lot of unnecessary lines of code can be generated and technical debt can be accumulated if you just rely on, these pure code generation tools. And lastly, to follow up, you can connect to LLMs on Intel Gaudi accelerators, or it can be, whatever cloud provider and endpoint that you have to connect to using just an OpenAI compatible API key. And then here I've linked for Denver DataWorks, that same website I showed earlier. And there's also actually, there's a way we can chat together on Intel DevHub Discord. So it's where one of the places that I interact with other developers. So you're welcome to join that and talk with me there. And if for some reason I'm not responding there, please feel free to reach me on LinkedIn. So happy that I could show you some of this tool, and I hope that this is helpful for you as you maybe look to build your own agentic workflows.